Okay, so what we go through today is the other two main types of fronts. I'm also going to stop in because I did add some animations into the presentation to better illustrate kind of how the air masses are moving in these different types of fronts. So the first one is looking at a cold front. Remember, a cold front is a mark the map, blue line, blue triangles pointing towards warm air. The other way to remember this is the triangles kind of indicate the direction that air temperature is moving. So blue is cool air. So the cool air is moving towards the warm air. So you kind of see here, and I didn't the symbols down here, but we have the cold air mass over here to the left, right, and it's pushing into the warm air mass, and it creates sometimes a storm system or rain as it pushes that warmer, humid air up. As it cools down, it creates precipitation. Okay. The other example here, remember, is a warm front that's associated with kind of warm air is retreating or it's moving over the top of the cold air. Again, the warm air is moving, and it's moving in the direction of the semicircles. So you can see again, here's the semicircle, so the warm air is moving over the top of the cold air, and that cold air is kind of retreating, getting pushed back. But again, as that warmer, humid air increases in elevation or altitude, it does start to cool off, and as it cools off, those droplets get bigger and it forms precipitation. Okay. So the next front we're going to talk about today is a stationary front. So a stationary front is basically it's different air masses, more or less just kind of smashing into each other and then not really moving. And so let me get down to this. So with a stationary front, again, what we see is we see alternating the blue triangle and the red semicircle. That indicates that it's kind of equal direction, so it's really not moving. They're just kind of pushing into each other. A lot of times we say it's stationary, so think of like a stationary normally means that it's not moving, but it does still move a little bit. So it's going to kind of, what we call it down here, I'll say it'll meander, or it kind of shifts kind of slowly back and forth depending on which air mass has more energy. So when we're kind of looking at the animation here, the stationary front, they just simply collide. Again, the air begins moving up, the warmer air moves up carrying moisture, and we create rain and we get storms. A lot of times stationary fronts, we tend to see just drizzly rain kind of all day. So it's just kind of a miserable day. Okay, and the last type of front is an occluded front. And this is where we use a purple marker here. To get back to the definition page. Okay, so an occluded front, it's a complicated process where basically warm air gets surrounded by colder air. So this gets occluded, so it's going to be a cool type, but basically it's a surface low where we get warmer air, gets surrounded by cold air. And since it moves in kind of a different direction, sometimes it'll even rotate a little bit. We see the alternating, symbols, but now they're purple because the air temperature will be in between, or the temperature will be in between. So there's normally two types. There's a cool type and cold type, and so we'll kind of look at some of the examples. So here we have our occluded front, where we have kind of the cold air mass pushing, and basically another cold air mass to the other side. So we have this warm air that gets trapped in between. So what it does is it simply pushes all that warm air up very quickly, and this is why we get some more violent storms. So you can see here we have a lot of rain, a lot of snow, because they have all that warm air. There's a lot of humidity, a lot of moisture. Warm air tends to hold a lot more moisture, so as it gets pushed up, we get these bigger storms. So again, looking at this, we have our, the advancing cold air, pushing into a warm air mass, but there's also a cold air mass on the other side. So again, we have all this warm, moist air now that is beginning to cool rapidly. As it cools quickly, we create storms that can dump a lot of rain in a short period of time. Okay, so here's kind of another example. Looking at this, we have the cold air pushing into the cold air mass. If you notice here again, this air mass normally isn't moving, or if it is, it's moving very slowly. But here we have this cold air mass pushing into the other cold air over here. Okay, so I'm going to leave off there for today after talking about going through the stationary and occluded fronts and kind of going over the cold and warm front quickly again. What I'm going to go through tomorrow is going to go through kind of how a cyclone forms, looking at these different types of fronts. One thing I did forget to go through quick, let me get back to it, is kind of looking at the actual weather maps. So until I add some more of these into the presentation, we can kind of see here, like we have is our stationary front, we have the alternating blue and red. So again, this area here is where we have a warm air mass. The warm air mass is going to be on the left here, pushing to the right. Remember, the little indicator here indicates which direction that air is moving. So the warm air mass is moving to the right, the cold air mass is moving to the left, and it collides right here and it creates that stationary front. You can see out in kind of Northern California here, where we have an occluded front. So again, this is where we can see that we have the kind of the warm air and cold air is both moving. So we have a cold air mass here that the warm air mass is getting pushed into by cold air behind it. This also adds in the kind of the H and L for the kind of the high and low pressure systems. So remember, a high pressure system, the air is basically hits the ground, so it's moving downward, and it creates a circular motion. Low is where it's moving, basically being sucked up from the ground up, and it's moving in a counterclockwise. So you can kind of look and see what's happening with the kind of high pressure system moving clockwise here, and lower pressure system. You can see that everything wants to move in this direction. Again, same thing, low pressure system, it's moving in the counterclockwise, so it's pushing it up to the northeast. Okay. So like I said, tomorrow we'll continue with the cyclones and what a cyclone is. If you have any questions or need help with anything, feel free to email me or check into the Zoom session at 10 a.m. Otherwise, have a good day.